Good morning, good afternoon, or good evening, depending on where you are. My name is Silvano Coriani. I'm a program manager in the Azure SQL team, and I'm here today to share some of the best practices and techniques that I've learned working with customers that have used Azure Data Factory and Azure SQL Database as a destination for their data movement or data transformation tasks. Right, so the agenda for this next 20 minutes, we'll start talking about the Azure SQL Database Connector, and we will go through some of the concepts like how we can securely authenticate to SQL Server or to Azure SQL Database, the copy activity as the main kind of data movement technique that we have in ADF to move data into Azure SQL DB. And then we will dig into some of the best practices and scenarios when we have to, for example, kind of append data, so load data into Azure SQL DB, or for example, when we have to upsert. Upsert means we need to discriminate if a row with a certain key already exists, and then just update it, or if not present in the destination table, just make a new insert, right? We will also consider when we have special kind of custom bulk load logic that is needed, and we will see how some of the techniques we have are actually available. And we will briefly touch also on mapping data flows that are another important feature in Azure Data Factory to load data into Azure SQL DB as a target. Okay, so let's start from how we connect to Azure SQL DB from within Azure Data Factory. Right, so the Azure SQL Database Connector is providing this kind of base connectivity to Azure SQL DB for all the different type of activities we have within Azure Data Factory. Right, so either is the copy activity or a mapping data flow, or one of the other activities like lookup, which is giving us the ability to retrieve a data set that we want to use subsequently in the data transformation pipeline, or get metadata to extract information from our SQL database target or destination, and take some decisions during the execution of the pipeline itself. The connector for Azure SQL DB does support SQL authentication and Azure Active Directory. If we use SQL authentication, for example, we can rely on Azure Key Vault for storing secrets, so like password and user ID that we want to use. And we can also use an Azure Service Principal, Azure Active Directory Service Principal, or managed identity, so assigned system managed identity to our Azure Data Factory pipelines, so that we don't need to store any credential anywhere, but just give our pipelines full access or limited access to our sources and destinations in Azure SQL DB. When we extract data out of an Azure SQL DB database, we can specify a table name, of course. We can specify a query that can filter just a subset of the data in our source database. For example, we can use a watermark type of approach to only extract the new data in that set of tables starting from a given point in time. We can invoke a storage procedure, of course. And when we need to load to extract a lot of data out of a source SQL DB, we can actually leverage a parallel copy, right? So the database SQL DB connector can actually manage all the details around partitioning the source data set, and you can specify kind of upper bounds and lower bounds for all the partitions, and leverage parallel threads that are basically making the extraction of your data source faster, right? But we will focus in this particular presentation in using Azure SQL DB as a sink, or also as a destination, right? And for this, Azure Data Factory by default is using bulk load wherever it's possible, and we will see how. and it can create a destination table if this doesn't exist. So you can specify this, and you can also, if you need, again, to specify a very specific custom logic during the copy process, you can specify and invoke a storage procedure while the pipeline is executing, passing basically batches of rows that are coming from whatever whatever source we are using as part of the pipeline, and then basically making sure that the storage procedure gets invoked, and you can specify some logic there that can transform the data or can just take decisions on how data will get inserted into our destination database. So let's see how the copy activity actually works, right? So copy activity takes information from a source data store and basically moves data to a sink data store, right? So if we look at the end-to-end process, we have a source here. Source is connected to the integration runtime, which is basically the engine running our pipelines and our copy activities in ADF. And the integration runtimes connect to the source through a network connection. Typically, this is a WAN or a LAN connection. Integration runtime can sit in a managed VNet, and so can connect to our sources and to our destinations through private links. So in case you need, again, to provide a fully secure end-to-end pass data movement and transformation solution, ADF can definitely provide that with SQL DB and as a source or a destination, even if this is sitting within a VNet and through private link, right? And then the integration runtime is managing things like again, parallelism, so spinning up multiple threads to read, to deserialize, decompress, map columns between sources and destinations, do the data movement, and so on, right? So you don't need to care about these details. We will see, it's important to understand how it works because performance can vary depending on how you are setting parameters here. But again, this is completely automatic behind the scenes. Some things to consider, for example, if we are using Azure SQL Database serverless, that is one of the options, one of the service tiers we have in Azure SQL DB. You need to consider that serverless databases can go and pause themselves, right? So it means basically shut down after a given period of time that you can set. So this means that the first time you are trying to access that paused database, it takes around 50, let's say typically 30 to 60 seconds in order to wake up, warm up, and wake up. So if you want to use a serverless tier as a source or a destination, make sure that you have set retry and retry interval in your copy activity. That's a parameter we have. We'll take a look at this later in order to make sure that the database is up and running, right? So copy activity is not the only type of activity that can target Azure SQL DB as a sink or as a destination. We also have Azure Functions, storage procedure activity, data flows, and Databricks notebooks, for example, that we can trigger. They can all use SQL DB. But let's focus for now to the copy activity, right? So what are the important things to keep in mind? So first of all, data integration units are, as I said, are basically the engine behind the scenes that is executing data movement. So it's very important to consider these settings, like the data integration unit and the degree of parallelism for the data copy activity in order to get the right level of performance. I'm going to show you a demo later on to say this. For append data, so whenever we have to just load the data as fast as possible into a destination table, which is typically the scenario we have, it's important to look at what are the options that we have in our copy activity for the sink. In particular, pay attention to the max concurrent connections here. By default, ADF is taking care automatically, but you may want to understand what's going on in order to be able to get the max out of your copy activities with Azure SQL DB. In particular, the max concurrent connections here and the write batch size are two parameters to keep an eye on, and we will see later on why this is important. The upsert scenario, as I was saying, is very peculiar. Sometimes I met customers having a lot of issues in basically upserting data because they were basically checking row by row if the row was existing in the target database, starting from the new set of data that they had to bulk load. And this is, of course, very slow. If you have millions of records in your target table, and if you are inserting hundreds of thousands of new records, and you are checking record by record, this is really, really expensive. Right? So the recommended approach here is typically to bulk load the entire new set of rows that you need to upsert into your target table. And then after this can be done in a traditional kind of persistent table or in a temporary table, especially the global temporary table that can persist multiple connections. And then after you have terminated the bulk load is ended, you just call a storage procedure that can do the merge between the new data set and the existing target table, making sure that these operations are done basically in bulk. This can save you. So one example, I had a customer that with the previous technique, was uploading around 100,000 new records in a 25 million records table, was taking like 20 hours. Right. By applying this approach, they reduced from 20 hours to around 10 minutes the entire copy operation. Right. So this is typically the best approach you can have. And in general, it's always preferable to bulk load data into SQL and then do all your transformations and operations within SQL rather than going back and forth with a lot of round trips between ADF and SQL Server. As I said, if you have very specific logic to put in place, you can target a storage procedure, execute a storage procedure once every batch of rows that you are inserting. How to do that is relatively simple. You can define table value parameters, so a new type that is basically representing the new rows that you are pushing into Azure SQL database. And then you define a storage procedure in your SQL Server, in your Azure SQL DB target database, which is accepting that new data type, new table value parameter, and is, for example, using merge, as I was saying, to execute that upsert operation. So when a row already exists, is basically updating whatever column in the existing target table. When the row doesn't exist yet with a certain key, is basically inserting the new row. Right, so this is a very classic type of approach that we can have. What is important to check on Azure SQL DB is that every compute size and service tier in Azure SQL DB comes with a set of kind of resources assigned, CPU, log throughput, and so on. It's important that when we are loading into Azure SQL DB, we understand what those limits are. Right? So we have full documentation in the Azure SQL DB site that is specifying exactly what are these limits and what is importantly this max log rate. So the capacity of SQL Server in ingesting new data. Of course, every size comes with, this is just an example, a max log rate, so a given amount of megabytes per second that it can ingest. So ADF, Azure Data Factory, is giving you performance tuning tips in case you are trying to push too many data into your SQL DB instance and you are exhausting these limits, right? So if you are reaching the limit, but you can always check with this DMV, this dynamic management views, sysdm user DB resource governance, what the max and mean log rate are for your database. So let's take a look in the time that we have to demo that I have here. It is a very simple demo. I'm taking data from a blob storage, and I can show you I have 5 CSV files here for a total of 25 million rows. They are partitioned like 5 million rows per file here, right? And in this activity, in this pipeline here, I'm just pointing to as a source to my blob source, and as a sink, I'm pushing data into my SQL Server destination, okay, Azure SQL DB destination here, and I'm leaving everything as a default. All the options that I was mentioning to you are default. Now, for the sake of time, I executed this pipeline a few minutes ago, and it took like 18 minutes, right, to copy around 3 gigabytes of data, 25 million rows, 18 minutes, right, which is typically quite a lot. So if we look at the details of my pipeline execution, we can see that the throughput was kind of low, 2.5 megabytes per second. And I can already see that, for example, I was using a few connections to connect and to push data into SQL DB by default, right? So this execution took like 4 data integration units and 2 parallel threads to copy this. So one way to start improving the situation here is I can pump the number of data integration units here, meaning I'm paying a little bit more in terms of cost, and I can also define an equivalent kind of degree of parallelism. And if I now execute the same, I'm just triggering again the execution of the same exact pipeline. Okay, we can see now is in progress, and we can take a look at what's going on here. Okay, and while this is ramping up, I just want to move on the SQL side, right? Where, as I was saying, I'm showing you with this DMV what is the min and max log generation rate that my database can accept is quite high, right? So it's around 100 megabytes per second. This is a hyperscale 8-core SQL instance. I can look at my current consumption of resources here. I can see that I'm using around 12% of the CPU and around 15% of my log write right now. So, and I can also, I'm going to show you this as well. I can use some of the usual monitoring techniques like looking at the current connections and requests that I have. And I can already see that now I have a lot more concurrent connections pushing into Azure SQL DB, right? By pumping up that number, you can see now the throughput is like 5x what we had before, with some spikes that are very, very interesting. Like now we are around 20 times faster or more kind of ingesting more throughput compared to previously, right? So this is already a good result, but as we can see here, by monitoring our SQL all the new records on a limited number of data pages in our database. And these are the data pages that we have, that we are contending, right? So a lot of concurrent connections coming from a number of hosts here. Again, this is completely managed by ADF. And so how can we improve the situation here? Well, we have typically 2 approaches. One is we can in order to reduce this page large contention, we can create a partitioned table. So this is a partitioned function and a partition scheme that I'm creating. So what I'm doing here, I'm just partitioning across these 32 partitions, like the number of parallel threads that we have in the system. And by doing this, if I go back to my demo, I'm just looking at give me a sec. Okay, I'm just killing this execution, and I'm just changing this to move my data set, which is the destination table. not to my target table, but to my partitioned table that I just created previously, right? So if I'm re-executing this, here it is. If I'm rerunning this, we can quickly take a look at where the system is waiting now. I'm expecting to still see some page latch waits at the moment is spinning up, but you know this case is going to be a lot more rare. As you can see, I don't have a page latch here. I still have some, but now the most dominating wait types is probably the async network I/O because again of the communications between network communications between the engine, right? So this way we are reducing a lot the amount of time that SQL Server is sitting there doing nothing, actually waiting for this contention to get solved. So by, again, partitioning our destination table is a good way. We don't have to change our code, our pipelines. We just introduce a partition function, a partition scheme for our database, and then we can use like an hash value that is a calculated column over an existing, for example, ID or a primary key in order to spread our insertions into multiple partitions. What can we do to improve this even further, right? So if we create a clustered column store on our target table, if this makes sense from a queryability perspective, this can also provide an additional boost in terms of transaction log generation rate and improving basically the ability of Azure SQL DB to ingest more data, right? Given the same number of cores and the same size of our compute and storage. Okay, so this is again. We are still talking about a persistent table here. If, again, we want to do even further and go close to the limits that we have, we can also move to a temporary table, right? By just enabling the global temporary table actually disabling, sorry, the auto drop of global temporary table between different connections. By executing this command, we can make sure that in our pipeline, we can create global temporary tables and then access those global temporary tables in different activities, right? This is another way where we can bulk load efficiently data into Azure SQL DB and get the most out of our existing target, our existing sink in ADF. I think we are a little bit out of time here, so I'm going to recap quickly. So Azure Data Factory is definitely a great option for moving data and transforming data from and to Azure SQL DB. Copy activity is probably the most indicated scenario where we need to append or upsert data. It's important to understand that data integration unit setting and the parallelism impact, because this can give us the maximum throughput in terms of copy operations. Bulk insert into a staging table, and then if you need to transform something, just execute T-SQL-based transformations in ELT-like or ELT style is probably the best way to get performance during these scenarios. But if you need really complex logic during the insert, invoking the stored procedure and passing table value parameters for all the batches that we are loading is another great alternative. Other than that, all the usual SQL database best practices for data loading are still relevant here, right? So reducing the indexing of your target database, making sure that you are loading the right amount of data. You are not moving too too many data and so on that are not necessary. And all the capacity planning exercises, you will see a series on data exposed videos that is talking about capacity planning is super important to get the most out of our ADF and Azure SQL database solutions. Okay, that's pretty much all I have for today. Thank you for attending this. Hope you found this useful. And if you have questions, I'm gonna reply to the questions on the Q&A panel. And thank you again for attending.